I'll give you all a handout today about the different types of amplifiers we have. They're called class amplifiers. And you can do all type of research on this. In fact, that's one of the things I should do is set up an assignment where y'all can go out and research amplifier classes. And then they'll come up here and tell you the different classes we have. The classes that we deal with in here are mostly analog classes and classes. And they left out one right here. So in here we're dealing with Class A, Class B, and Class C, and then Class AB amplifiers. It actually goes up through Class T, but anything above Class AB, these are digital amplifiers. So this is one we use for pulse width modulation, for generating strings, for electronic switches and stuff like that. These would be what we call Class B amplifiers. I'm sorry, any class between D to T. So this is a pretty good image right here. So right now we're doing what we call a Class A amplifier. Then we'll look at a Class B amplifier, Class C amplifier, and a Class AB amplifier, which the drawing that I had up there is not quite. So a Class A amplifier, it passes. So what we do, guys, is that we have to understand these amplifiers are usually designed for, except for switches. We know switches. Switches are basically just current amplifiers, right? You understand that? But a switch, we either cut them on, or we cut them off, or technically we call it saturation and cut off. We don't operate switches in what we call the active region. When we get into the amplifiers that we're playing around with right now, these are what we call Class A amplifiers. So what that means is no matter what type of AC signal we put into these puppies, we're going to get an image of the AC signal out. So technically, so even audio, guys, audio is just a composite of all different types of frequencies, right? Y'all understand that? So normally, and I'll try to hook up some audio and let y'all look at it with an oscilloscope. Music is really, really interesting. But what we have on audio is we have a low frequency component, which would be the bass, right? You understand? All the way up through all type of frequency components, all the way up to where we get into what we call our high frequency. Well, it's not really high frequency, high audio frequency range. And then it still goes, but your ears have what we call a bandwidth. And what is a bandwidth, by the way? So y'all probably heard about this all the time, especially in the internet. They talk about how much bandwidth you have, right? So what is bandwidth? Well, basically, technically, on the internet, it's the range of frequencies you're assigned. You're not talking about the bandwidth of the media. Normally what we talk about, every media can only handle, what is media, by the way? Passes through. So media is what information passes through. So every media has a bandwidth. So technically, when we're talking about the media, the bandwidth of the media is the frequency that the media can reliably pass. Okay. And what we're doing is we're looking at half power. So if I'm sending power, if I'm sending 100 watts of power through a media, and on the other side, if I can get 50 watts of power, then it would be within its bandwidth. When it drops down to 49 watts, so you're losing 51 watts of power in your media, then we say that's outside the bandwidth. And this occurs, by the way, is what we call minus 3 dB. So we talked a little bit about dB in this class, right? Now, when they talk about the bandwidth they assign you on your cable or your cell phone, they're not talking about the bandwidth of the media, right? You understand? They're talking about how much of that bandwidth they give to you. So right now, Spectrum is advertising 200 megabits of bandwidth that they assign to what? To you. When the bandwidth of the media is not near that, but what we can do now is we can compress, there's all types of techniques where we can compress the data. So technically the bandwidth of the coax cable on your house is only around 100 megahertz. Well, how can they get 200 megahertz on a media that's only rated at 100 megahertz? Yeah, they compress it. They compress the data. So what they do is they have what they call a baud, which is a carrier, and then they put multiple bits on the same part of the carrier, which is really, really. So there's a difference between your assigned bandwidth and the bandwidth of the media. So when we get into amplifiers are going to have a bandwidth, right? You understand? And that's why when you buy stereos and stuff like that, you just don't go out and buy that. You need to look at the specifications, and they'll give you the bandwidth that amplifier can do what? That it can amplify, right? You understand? So the way the way a bandwidth curve would look, we would come over here, and basically what we do is we can't measure power, right? You understand that? Why can't we measure power? We can. You can buy power meters, but they're very, very expensive. Why don't we measure power? Yeah. Why can't we measure power? Why don't I have a meter? Why don't my meter over there measure power? Why don't they make that available on a standard meter? Why do I have to pay thousands of dollars for a watt meter? Because they have to measure two things. They have to measure the voltage and they have to measure the current, and then they got to do the math, right? You understand? So what we do when we talk about bandwidth, we're talking about relative to voltage, because voltage is real easy to measure, right? You understand? So what we start off with is we start off with frequency on here, and then over here this would be voltage. And then what we'd find out is we'd come over here, we'd start out at almost zero on the media. And pretty soon it would come over here and it would take off. And then it would come over here and top out. And this would be the maximum I could get through the media. And sooner or later, when we get to a high frequency, what's it going to do? It's going to roll off and do this. You'll understand that so far? Okay. And what we do is we say, okay, this would be my V out max right here. And then, of course, what happens is somewhere along this line, we set a bandwidth, and we call this F1, and the upper limit we call F2. So we measure bandwidth by saying F2 minus F1. That's the way we measure bandwidth. But what would that be relative? What would half power be to, what would half power be relative to voltage? So if my voltage halves, what's going to happen to my power delivered? It's going to drop by how much? Well, what we do when we go up, it's V times I'm sorry. Yeah, well, it's the power squared. So what happens is when it goes up, it's your power times V squared, right? So that would happen to your power. When you go down, it's when it goes. So this is if the voltage goes up. When the voltage goes down, it's going to be the exact opposite, right? You understand? So this is going to be powers equal to 1 over V squared. So when it goes down, it's what? So if I half the voltage, my power is going to drop down to 1/4. You don't understand that? Well, when would the half power point occur? So we know if our voltage is right here, this can't be F1 because we're talking about F1 would be when my power drops down to 1/2. But the problem is we don't measure power. We got to figure out when I hit that 1/2 power point relative to what? To voltage. So what would that 1/2 power point be? What would my voltage drop down to get that 1/2 power point? It's a number we use all the time. So let's say I start off with 10 volts, right? You understand? Right? You understand that? Let's say I drop down to 10 volts. I have 10 volts, and this right here gives me my maximum power. So let's just use V times I, okay? So let's say 10 volts at 10 amps. So what would my power be? Be 100 watts. So voltage and current are directly proportional to each other. So this is why that happens. So if I half my voltage, then that would be 5 volts. Then I'm going to half my current. So what would my power be now? 25 watts. And not a lot of people don't understand that. So people don't understand if you half your voltage to a circuit, what happens to the current? It halves. Then power is equal to V times I. Well, let's say I come over here and I'm going to round this, guys. Let's say I drop my voltage down to 7.07 volts. That would cause my voltage, my current to drop to 7.7 volts. What would be my wattage now? Now 7.07, we're rounding that, right? It's actually the reciprocal of the square root of 2. So that'd be 1.4141414. And you take the reciprocal of that, and that's what we're not using that. We always use 0.707, right? You understand that? So what would this be? There you go. 49 point what? Yeah, 98. So it would drop down to 50 watts because we're rounding the 0.707. So if my voltage drops down to 70.7% on this side, then what happens to my power in my circuit? Well, my power delivered to my load would drop down to 50%. So this 0.707 is a number that we're using what? All the time. Which is a minus 3 dB, by the way. And this would set F1 and F2, and that would be my bandwidth. So people don't understand that. So that voltage has a very limited range, right? You understand? 70.7%, which means I'm delivering what? This is percent, which of course would equal to 0.707, which is what we would use. So I come into an amplifier. What sets F1 is what's going to set F1 is these capacitors that we use. And we're not teaching design, but all these capacitors that we would be using with. So what's the name of these capacitors? We call these two right here what? Huh? What do we call these capacitors right here? If I call this C1 and C2, what are C1 and 2? What do we call those capacitors? They have a name. No. Good guess, though. This is bypass capacitor right here. Because what does it do? It makes the AC signal bypass that resistor. Right? Just like when we talk about bypass on audio, when we talk about bypass, right? What does it do? So that big freeway, that big toll road that they put down in Gulf Shores, they call that a bypass because what do? you bypass Highway 59, which goes through all these little old small cities, right? And if you go in there, if you try to get out of there on a Sunday when everybody's coming home, you go through those little, or you go down there on Fridays when everybody's trying to get down there, right? So yeah, we call that a bypass capacitor. What do we call these? These are called coupling capacitors. Because what they do is they allow us to couple the AC into a DC circuit, right? You understand? So these are called coupling capacitors. So these guys right here, if I call this C3 down here, these guys right here set the low frequency right there. Because how much opposition they get is 1 over 2 pi FL. So the lower the frequency that we have, so you'll see these guys being a pretty good size, probably 100 microfarads or above. We're not going to get into the formulas. I think the formula might be in your book, but what you got to understand is that when we choose these capacitors and we choose these resistors, what we're doing is we're setting F1 for the circuit. Now what sets F2 is the transistor itself. So what happens is the frequency goes up and up. What happens is this guy here acts like a little old small capacitor. And what happens because of the barrier voltage. And what happens when we get up to a high enough frequency, it bypasses the base because it's so close together, and we lose control of the circuit. So there's a specification in the data sheet called FT, and that you'll use that in a formula to figure out F2, right? You understand? And what would you use to try to figure out F1? You use the size of these capacitors. Whichever one gives you the highest XL, that would be what you set F2 at. F1. So all these guys are going to have a bandwidth, right? You understand? So when you look at your stereo, when you go out and buy a stereo, or when you buy just about anything that deals with audio, one of the things they're going to give you is the what? Is the bandwidth. But they're going to give you F1 and they're going to give you F2. So they'll say this stereo works between 30 hertz and 20,000 hertz. And that would be pretty good for you because most people can't hear 20,000 and most people can't hear